All right, let's dive into one of the most game-changing features in modern Java, streams. We're going to break down how you can use them to write code that's not just cleaner and more readable, but way more efficient. Let's get right to it. So let me ask you a question. Are you sick and tired of writing those long, clunky, nested for loops just to get through some data? You know exactly what I'm talking about. The ones filled with temporary variables, tons of boilerplate, and conditions that make your head spin. If you're nodding along, then you are in for a treat. And this right here says it all. On the left, that's the old way, that tangled mess of a for loop that's just a pain to read. But look at the right. That is the new way, a single, elegant chain of operations. This is the real magic of the Stream API. It's declarative. You're just describing what you want done, without getting bogged down in the messy details of how to do it. To really get how this works, you gotta think of a stream as a kind of data pipeline. Or, like a conveyor belt at a factory, but for your data. So let's pop the hood and look at its anatomy. So what is a stream, really? Well, think of it as a pipeline that processes a sequence of data as it flows by. And here's the most important part to remember. It's all about processing data, not storing it. A stream is a river, not a lake. Now, what's so cool is that every single stream you ever write follows this simple three-stage structure. That's it. You have a source, then some intermediate operations, and finally, a single terminal operation. Let's take a quick look at each piece. First up, every pipeline has to start somewhere, right? And that's the source. It's simply where your data comes from, the very beginning of the conveyor belt. You can fire up a stream from just about anything. A list, an array, you can even stream lines directly from a file. Next up are the intermediate operations. These are like the different stations along that conveyor belt. Each one takes the stream, does something to the data, transforms it in some way, and then passes it along to the next step. We're talking about things like filtering out items you don't want, mapping elements into something new, or sorting them. And finally, we get to the terminal operation. This is the end of the line, and it is absolutely crucial. This is the step that actually kicks the whole pipeline into gear and gives you a final result, whether that's collecting everything into a new list or just doing something with each element. Okay, so now that we've got the basic structure down, let's go over a few essential rules you absolutely need to know to use streams the right way. The first rule is also one of the coolest concepts. Streams are lazy. What does that mean? It means when you chain together all those intermediate steps like .filter and .map, absolutely nothing happens yet. Seriously, the stream is just building a blueprint of the work to be done. No data actually gets processed until you call that final terminal operation. Rule number 2 is a huge gotcha that trips up a lot of people when they're starting out. A stream is like a concert ticket. Once you've used it, it's spent. After a terminal operation runs on a stream, it's considered consumed, and you can't, for any reason, use it again. And this code shows it perfectly. We make a stream, right? The first call to .foreach works like a charm, no problem. But then, if you try to call it a second time on that exact same stream variable, nope, you're gonna get an error. The stream has already been used up and closed. And rule number 3 just clears up a really common point of confusion. A stream is not a data structure. It's not like a list or an array. It doesn't hold on to your data. Think of it more as a view that carries values from a source through that processing pipeline we talked about. Okay, now for one of the most powerful features baked right into streams. That whole pipeline model we've been talking about, it makes it incredibly easy to unlock the power of parallel processing. A parallel stream is pretty much what it sounds like. It automatically breaks your data processing job into pieces and runs them at the same time across the different cores in your CPU. This can give you an absolutely massive performance boost. But a word of advice, it's best for really large data sets or tasks that are computationally heavy. That's where you'll see the biggest win. And this chart just says it all, doesn't it? For a big, complex job, a regular sequential stream might take a while. But by making one tiny change, literally just changing .stream to .parallel stream, you can slash that processing time. It's an incredible amount of power, and you don't have to write a single line of complicated multi-threading code yourself. All right, theory is one thing, but let's put it all together. Let's see just how elegant and powerful streams can be in a practical, real-world kind of scenario. So here's a pretty common task, right? You've got a list of employees, and your boss wants the names of the top 3 highest earners. Now, with old school loops, this would be kind of messy. You'd have to sort things, keep a counter, add names to some temporary list, it gets complicated fast. But with a stream, just look at how clean this is. We start a stream from the employees list. Then we sort it by salary in descending order. After that, .limit3 gives us just the top 3. Next, we map each of those employee objects to just their name. And finally, .toList collects the results. The code literally reads like a description of the problem. It's beautiful. So what's the bottom line here? Why should you make the switch? Because streams give you code that is so much cleaner and easier to read. They're declarative, so you can focus on the what instead of getting lost in the how. You get to ditch tons of boilerplate, and they're built to be parallel ready for some seriously amazing performance gains. So we've seen just how powerful and elegant Java streams can be. But like with any powerful tool, it's just as important to know when not to use it. And that brings me to a final question for you to think about. With all this power, can you think of any situations where a simple, old-fashioned for loop might actually be the better choice? It's definitely something to consider as you master this amazing feature. Thanks for joining me on this one.